Superposition theorem is a theorem which is exclusively used to justify whether the circuit is linear or nonlinear. Let's consider this circuit where by applying superposition theorem we are supposed to find out the individual branch currents I1, I2 and I3. Here I will discuss how the entire process will be done. Actually, to show the superposition theorem, circuit has to satisfy two properties. One is homogeneity property and another one is additivity property. In this circuit, two voltage sources are shown. So, you have to consider at a time only a single voltage source. In first case, here we have considered V1 voltage source. At that time, V2 voltage will be eliminated from the circuit or it will be replaced by using its internal resistance or by short circuiting that branch. Later on we will discuss why short circuiting is used here. Anyway, for the first case, V1 voltage source has been considered and we have to redraw the circuit and mention the currents accordingly. In second case, we have to consider the V2 voltage source and again you have to draw the circuit and mention the branch currents accordingly. This individual consideration of voltage sources is actually the homogeneity property of the circuit. Next, to find out the individual branch currents, we have to consider the additivity property that will show the summation of branch currents for individual circuits. Like here, the branch current of the main circuit I1 equals to I1 dash plus of minus I1 double dash. Here you have to consider the original current direction. Actually, I1 dash is maintaining the similar direction of the actual circuit current I1. So that's why I1 dash has been considered as positive. On the contrary, I1 double dash is just opposite direction of the actual current direction I1. That's why I1 double dash has been considered as negative. In the same way, branch current I2 equals to I2 double dash minus I2 single dash and branch current I3 equals to I3 dash plus I3 double dash. In that case, I3 dash and I3 double dash both are maintaining the same direction as I3. So I3 dash and I3 double dash both are considered as positive. Thus, branch currents are shown here. This is superposition theorem. We have already seen that whenever you are to eliminate any voltage source from a branch, at that time it is eliminated or replaced by short circuiting that branch. The reason is explained here. Actually, the practical voltage source is represented a voltage source with its series resistance or its internal resistance. Now the voltage drop across the load is the supply voltage minus the voltage drop across the internal resistance. But whenever internal resistance is 0, at that time the voltage drop across the load is always the supply voltage. It does mean that whatever the load resistance, okay, but the drop across that load resistance equals to the supply voltage, because the internal resistance of the voltage source at that time equals to 0. In that case, we will consider that voltage source as ideal voltage source. So, whenever any ideal voltage source is of concern, at that time this voltage source is replaced by its internal resistance, that is zero resistance, and that zero resistance is possible only when the branch is short circuited. That's why a voltage source is eliminated or replaced from a branch by applying a zero resistance across that branch, or by making the branch short circuit. If any current source is there in the circuit, it will be replaced by making the branch open. Thank you. If you get benefit from my lectures, then kindly subscribe my channel and share my videos. Thank you once again.